Hi, I'm Miss Hearn. If you like this video, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. Now, sometimes we will have a trig function composed with an inverse trig function. So let's see what happens, for example, with sine of arc cosine of -1/2. Remember, arc cosine just means inverse cosine. Okay, and we just actually found the inverse cosine of -1/2, didn't we? What did that turn out to be? 2 pi over 3. So this is really asking us to find the sine of 2 pi over 3. So what's the sine of 2 pi over 3? So we're here, we're in quadrant 2, 2 pi over 3. So the sine is going to be the root 3 over 2. Is it going to be positive or negative? Positive, because we're above the x-axis. So that's going to be just root 3 over 2. Okay, that's how it works when you have one of our special angles that we've memorized. A lot of times, though, we will not. So we'll have something like cosine of arctan of -2/3. All right, so you cannot actually evaluate this. There is no exact solution here. You could get a calculator approximation of that, but that doesn't mean that there's not an exact solution for the whole expression, because we can use triangles. We can use right triangle trigonometry. So what I mean by that is, okay, arctan, so is arctan going to be in which quadrants are arctan? Let's go back up. Let's look. Arctan, remember, was between -pi/2 and pi/2. That was quadrants 1 and 4. So we're in quadrants 1 and 4, but we're negative. So that means that we must be down in quadrant 4. Okay, because the tangent is negative. Okay, and then we can draw a right triangle, and you can either think of this angle as having a tangent of theta equals -2 over +3, or you can think of 2 over -3. Which one works here, though? So remember, tangent we think of as being y over x, and the y is negative in this case, isn't it? Because we're in quadrant 4. So I'm going to think of it as -2 over the x value being a +3. So this would be a picture of my right triangle. All right, I am looking for an angle theta that has that tangent, but I can't find it. But guess what? Whatever it is, we're taking the cosine of it. So the cosine of theta we can find. I couldn't find actually theta itself because it's not a special angle, but I can find the cosine of theta. So how do we find the cosine of theta? We would need, if this is theta, we would need the adjacent over the hypotenuse, yes? So I would need to find the hypotenuse. How can I find that? What's that theorem called? Pythagorean Theorem, that's right. So I'm going to call this hypotenuse, I'm going to call it R, because that's what we usually call it. Okay, so we're going to have that -2 squared plus 3 squared equals R squared. So that means 4 plus 9 equals R squared. So R is the square root of 13. By the way, R is always positive. Okay, so the cosine of theta is going to be x over R, adjacent over hypotenuse. So in this case, cosine of theta would be what? 3 over square root of 13, right? Of course, you can rationalize it by multiplying by root 13 over root 13. You get 3 root 13 over 13, and you're done. Okay, so when they give you something that is not a special angle, that is how you can approach the problem. Okay, so let's do one more. First of all, focus in on the inner part. We're looking at an arcsin. Arcsin means which quadrants? There we go, quadrants 1 and 4. So when we're thinking about this, we need to focus on either quadrant 1 or quadrant 4. Quadrant 1 if it's positive, quadrant 4 if it's negative. It's quadrant 1 because it's a positive 1/3. So we're talking about something that has some angle theta, so that the sine of theta equals 1/3.
So sine is opposite over hypotenuse. So I'm going to think of this side being 1 and this side being 3. That's the y over r, right? All right, but what we want is to know in that case, what would tangent of theta be? So tangent is y over x, opposite over adjacent. So we would need to know what the x is here. And how do we figure that out? Pythagorean theorem, yeah. So we're going to say 1 squared plus x squared equals 3 squared. So that means x squared equals 8, which means that x is square root of 8, 2 root 2. Is it going to be positive or negative? Positive. How do you know that? X equals plus or minus the square root of 8. We're going to use positive 2 root 2. First quadrant, the x's are positive. Very good. So the tangent of theta is going to be y over x, which is going to be 1 over 2 root 2. Good. And if we rationalize that by multiplying by root 2 over root 2, what would it look like? Square root of 2 over 4. Okay, any questions about that one? Okay, so this is all review, but I really felt it was important that we do that because we're going to need to use expressions like this one, cosine arcsine of x, where there's no number. Okay, and so it actually turns out you can write this expression without any trig functions at all, which is crazy to me. So watch what happens. So we're going to start with focusing again our attention on the arcsine of x. So what I mean by that is I want to think about, okay, what do I know about arcsine? It's in quadrants 1 or 4. That's something that I know. Yeah. What I'm saying here is that the sine of some angle theta is equal to x. We usually like to think of it as a ratio, so I'm going to think of it as x over 1. Okay, so the sine of theta is x over 1, and I'm in quadrant 1 or quadrant 4. For the moment, let's just focus on quadrant 1. Everything else will be related. Here's my angle theta. It has a sine of x over 1. So that means opposite over hypotenuse. So then what would be an algebraic expression that would represent this guy here? So we could use the Pythagorean theorem. We know that whatever we're missing squared plus x squared is equal to 1 squared, right? You agree with that? So that missing guy squared is 1 minus x squared. So that missing guy would have to be this plus or minus the square root of 1 minus x squared. Is it going to be plus or minus? Yeah, no matter whether I'm in quadrant 1 or quadrant 4, actually, the x value is positive. We're to the right of the y-axis. So that missing piece is just the positive square root of x squared. So I can put up here square root of 1 minus x squared. Okay, so now we're looking for the cosine of that angle theta, because this whole, I don't think I wrote that clearly, this whole thing here is an angle theta. And we don't know what theta is, but we can still find its cosine. We can use the relationship cosine of theta is adjacent over hypotenuse, which in this case is going to be what? The square root of 1 minus x squared divided by 1. So the cosine of theta that we were looking for is just 1 minus x squared, square root of that. So what I just showed is that the cosine of the arcsine of x can be written as square root 1 minus x squared. Doesn't even have to have a trig function in it. What we're mostly interested in though today, remember, was derivatives of inverse functions. Okay, so now that we've done all of that review, now we're going to apply these ideas to finding the derivative of the inverse sine.
And that's what we're going to do in the next video. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Earn Mathematics, for more math videos.